Right, I'm just going to turn my timer on, which will yell at me if I go too long. Okay, we're ready? Hello, my name is Lou, or Luke, either's fine. And the name of my presentation is CellPond, Spatial Programming Without Escape. Okay, so part 1 will be about spatial programming, part 2, CellPond, and part 3, Without Escape. So, just checking, how am I doing for time? Got a few more minutes? All right, okay, I better speed up. Okay, so 23 years ago, I was 6 years old, and I liked trains, right? And I also really liked computers, right? So this is what I grew up with. Wow, I'm so old. And so I was really excited when my class at school got taught how to code with something called Stagecast Creator. Any Stagecast fans in the house? There isn't usually, but I was, and it works like this, right? You drag and drop to make spatial rules. Here I am making a rule for my character, and here it is in action. My character moves to the right. You make a before and after picture. When this happens, then this happens. When there's space to the right of my character, they move right. When there's an obstacle to the right, they jump over it. You can make lots of amazing things with this extremely simple idea. And because of that, at the time, it was a very popular style of visual coding. And they also loved trains. Like, they seriously loved trains so much. And it was so sad because it was so hard to code trains with spatial programming, for me and for them, because of this thing called and I can't pronounce it, but basically what it means is that you have to make lots and lots and lots of rules to make certain simple things, like trains moving around a track. And it's even harder if you're working in 3D, and I found out the hard way. That's how many rules you have to make something very simple. It's also really hard to make different things act the exact same way. So it's hard to make a car move along a road like a train moves along a track. You can do it, you just need to write loads of rules, which is really annoying. So we gave up. And we turned, I know, and we did this instead. Does that look familiar? Yeah, you see, does that look familiar? When we turned to block-based coding, spatial programming died, right? The end. Thank you for coming to my talk. No, all right. I'm just joking. There are loads of there are dozens of us, all right? This is Splat. This is by Dave Ackley, a spatial programming language designed for a new kind of computer architecture, which is robust first. This is Color Code by Murillo Pelays, an artistic and beautiful puzzle. This is NetBiodin, a spatial programming tool intended for research, biological, chemical simulations. This is Viscit, another educational tool. It shows us how to do spatial programming without a grid. And I made one too. This is SandPond. You code it like this, with before and after pictures, to make different elements like sand, water, and rock. Spatial programming is used for education, hardware, art, simulation, and games. Spatial programming is general purpose, and so I think it's worthy of our attention. But it has a dark secret. Can you see it? Can you see the secret? Can you see the dark and terrible secret? You can't see it because this image is cropped, right? Here's the full image, right? You see what text? How did you know? So spatial programming makes heavy use of escape hatches. If you want to do something simple, it's fine. You can do it with the spatial programming, the rules. But if you want to do something more complicated, you have to use normal programming. They all do it. Even Stagecast Creator. It's not even a spatial rule. These are instructions. They're lines of code. If you want to have more fine-grained control over it, you have to deal with it. I mean, color code doesn't have any escape hatches, but it's more limited. You know, That's intentional. It's part of its design, it's part of its beauty. But is that really our choice, right? Powerful with escape, or limited without escape. Could we make something that's powerful without escape? Is it possible? What would it look like? Will there be any unexpected and enlightening lessons along the way? So this takes us to part 2, CellPond. It's demo time. Whoop. All right, I gave it a go. All right, this is CellPond, and you can paint in it, and you can clear the screen, and you can paint in it some more, and you can clear the screen. Can you see we're painting with white right now, and that's because in the top left up here it says white, but you can open this up and see that this white is just made up of red, green, and blue. So you can just like click on these and change them. Does that make sense so far? Yeah, and you can like do that with all of them. If you're undecided, you can pick a range of colors. Do you see that? Yeah. Oh, yeah. Oh. You see that range? And I like that color, so I'm gonna just keep it safe here on that paddle. Does that make sense so far? Are you following? If you're really undecided, you can just like, blue or green, I don't know, just put them together. And then we've got blue or green, a new color. It's called blue or green. I'll keep that one too. If you're really extra undecided, you can just like remove some of these color channels. You just chuck them off the screen, yeah. And now I'm only drawing into the red channel. Can you see that? Ah, yeah. So here's red. You could draw into the blue. No, sorry, green. And then and the blue. You see, it's like mixing together. I'll keep that one too. Another thing you can do is do you see this triangle? Do you see how it's kind of pointing to the right? Well, you can point it up or down or like any way you want. So I'm going to point it up, and then I'm going to put that in one of my channels. Yeah, so now it's increasing green, yeah, or maybe increasing blue, or red, but then I could also like reduce red, but it's not touching the green or blue. Do you follow it? Yeah. Do you know what I like doing is you put one up, and then another one to like full. Oh, yeah, did you see that? That's nice. Anyway, so another thing you can do with the triangles is make a rule. See, green becomes something else. I am going to pick, and it's really important I pick pink. All right, so green becomes pink. Now watch it, because this will happen fast. Do you see that? I'm going to pause it, put some green down, unpause, it becomes pink. Do you see that? I'm going to turn off the rule, put some green down, turn back on the rule, it becomes pink, yeah? So that's a very simple rule, but it's more interesting. Ooh, everything becomes pink. All right, so it's more interesting when you have a rule that's bigger than just one square. So I could say if pink is above black, then we're going to replace that with pink below black. So now our pink is falling down. Can you see that? And you can make these any shape or size you want. There's no limitation like most other spatial programming things. All right, you can say if pink is kind of like up and above to the side of black, it's hard to explain with words this, right? But it's just obvious when you see it there. So like if I put down this pink now, it's falling down and it's falling to the side. Both of these rules are randomly firing. It's super non-deterministic, super random, but still it's making something compelling that we can understand. I want this to happen to the left as well. So it would be annoying if I had to make another rule. So I have this little circle, and it's like a mirror. I'm going to flip this left and right. And now, when I drop it down, I've made pink sand in CellPond. Can I get a round of applause for pink sand? Yeah. Right. And you can just keep doing this. There are some I made earlier. So you can just like keep adding more and more rules to make more and more like complex simulations. I've got sand, I've got wood, I've got water, I've got rock, I've got plant, and I've got fire. All right, and you can make all sorts of things. Just keep adding more and more rules. There's one thing I just really want to point out. You see this top rule? I'm using that thing I showed you earlier this is sand or water or rock, we're making different things act the same way with just one rule. And this uses a really key concept that I've always failed to explain, called conservation, and CellPond does it. So I'm going to try that. It's world exclusive of Lou Wilson trying to explain conservation in CellPond. Okay, so first of all, I want to show you this green color is a range of greens. Yeah, it's not, they're slightly different. All of them are slightly different. And this one rule I've got here, it just says if there's black above green, then fill the black with green. Okay, so when I place down green, it starts copying itself upwards. But look closely. It's like every time it copies up, green stays the same color. It doesn't randomly pick a new green. And this is really important, CellPond uses what's already there in that little neighborhood to decide what to draw. You can always override this by stamping one of them, and that link gets broken. So now, rule of conservation is gone. And that's really important for allowing this consistency from one rule to the next. So that's my attempt. It's pretty dry, but please let me know how I can explain that better. All right, here's another one. In this first rule here, these colors are empty. They have no values in their channels. So I'm basically saying any color is fine. I don't care. Any color is fine. If I have two of anything next to each other, then they become two of anything next to each other, but they could be flipped. So what this is doing is it's randomly swapping things around, and that's how you get this diffusion effect. But you can play around with this rule of conservation. Which one are we going to place where by stamping one of them? And you end up with this Galuppi effect. Again, I find that this kind of behavior is really hard to explain with text and words, but when it's expressed spatially like this, you get more of a sense of it. It's more of a feeling rather than something you explain. And by the way, look, you can make them disappear at the edges. It looks nice. Ooh, there's no real point with that one. I just thought it looked nice. So do you remember earlier on I showed you could have a color like this where we're reducing the value of channels. And this works in rules too. So you can say in this rule, anything is just going to have all its values reduced. So no matter what you put down, it's just going to reduce down to 0. But you could have this only affect certain channels, only reduce the red channel, and you can make all sorts of different things with it like this. And this is also this is really important for storing data and information in CellPond. So here I've got this little ball. You place down a ball and you chuck it upwards and it falls down, right? And you can throw lots of them. And have a look. There's 2 stages. It rises up and then it falls down. And we're storing that stage in the green channel. As it rises up, green gets reduced. Have a look. Green gets increased. Green gets increased. And when green is at the top, it switches into the other stage. So even though these rules are firing randomly in any order, in any place, we've created a control structure. And that's how you can make more complex things. Just don't get these stuck on the ceiling. And by the way, when I say random, some people freak out and they think, is this even Turing complete? And I now present to you my proof that CellPond is Turing complete. Okay, please stop asking me about it. All right. I'm joking. But please don't. All right. So now you're ready to see the main thing behind CellPond. Okay. So do you see this rule at the top? Blue doesn't just become one other color; it becomes 2 colors. And this is CellPond's big idea. This grid is not fixed. You can merge cells together and you can split them apart. So watch this. Do you see what I've done here? I'm going to make it run a bit slower so you can see it. These cells are splitting. And I could just keep going in and we could just split more and more and more of them. For the 1 or 2 of you out there, no, this is not a quad tree either. All right. So this is another way that you can encode. I need to fix that bug. Please fix that. Please fix my bugs. It's open source. You can encode data by splitting. When you need to store more information, just split, and you've got more memory, more data where you can store stuff. So here, I've got these same little shapes, and they have one rule: move forwards into an empty space. But this rule, you see here, is flipped in all directions. That's a bug. That's not going back on. All right, there we go. Fix my bugs. But so you can place them down, and they're pointing up, and they'll go up. But I could just like rearrange this and have them pointing down. I could even add a rule that makes them like change and go in a random direction. Yeah, I could pause and zoom in, and I can look at any one of these and just see, just by looking, I can see what direction that has stored. There's no hidden stack or heap or register or there. It's all right there. I can see it. You see? Do you see it? Yeah. Yes. Thank you. Yeah. Okay. But you know that's less interesting. No one really cares about that, apart from people at programming conferences. People care more about this. If you make something split into more copies of itself, then you can make a fractal, and this will just keep going and just crash your computer like a normal programming language, which I think brings it legitimacy. But of course, like fractals are quite a popular thing to make in creative coding circles, and they're quite complicated. But I think this is a fun way of just seeing it. Look, I'm just drawing a new fractal. What if we swap it with this, which I've just made? And I place it down. Hey, we just made a new fractal. What if we just give it like random rotation every time it splits? Ooh, right. You know, I want to see more of this. Just in case anyone asks, yes, you can make trains. So let's say I make a nice little track, and like this. Oh yeah, ooh, yep, like that, and then I can pop a train in it, and we use some of those things to make a little train. It's No, wait, it gets better, right? Watch this, you can, I added like a one-way only track piece, so this will always turn right there, and then you can put two trains in and they won't crash. Yeah, that's what should have got the applause, but it's fine. How are we doing for time? We're good. So another thing I want to mention is that you can, choose a different resolution for CellPond if my default one is too boring for you. This is a nice, slightly bigger resolution. But of course, because you can split cells, you can just increase the resolution by yourself. So have a look here. Can you see that it's getting? Do you see that? Did you see that? I'm going to show you one more time, and this time you better be paying attention. All right. So I'm placing down this white square, and as it spreads around, it's splitting these cells into smaller cells. So I'm just increasing the resolution myself. However, some people weren't happy with doing this every time they loaded it, so I added a setting as well. But yeah. You can make nice high-resolution stuff too. We'll get back to that later. Part 3, without escape. Is it possible? Probably more possible than it once was. What would it look like? Maybe that. Will there be any unexpected and enlightening lessons along the way? This surprised me, because there was, right? The biggest breakthrough with CellPond was not its UI, right? The UI is just provocative. That's not the point of CellPond. Forget the UI, all right? The main breakthrough moment, after which everything just fell into place, was CellPond's virtual machine called Dragon, which is like drag and drop, and it has 4 main instructions: check, recolor, split, and merge, which are basically read memory, write memory, allocate memory, and deallocate memory. After this, everything else just slotted in. And I think if you were to learn from CellPond, you'd take this away, not the UI. But you can take the UI too if you want. I was very surprised by this, because all of my reading of things in the past, solutions to these problems were all about the high-level user interface. They were about the UI. I thought I'd have to build layers upon layers of UI, but really, as soon as low-level stuff was sorted out, the UI just figured itself out. So here's another example. This is a very simple rule. Yellow, if there's yellow above black, they swap positions. So I have a question for you. Is this yellow square falling down, or is the black square falling up? You think it doesn't matter, but most spatial programming languages force you to decide with this thing called origin, or sometimes it's like implicitly decided. At worst, it's slightly annoying, and at best, it just messes up your program. So we don't want to do that. So instead, when you make this panel in CellPond, it doesn't just make one rule, it makes a registry of multiple rules. All of those extra rules that were really hard to make before, well, let's just get the computer to do it, right? Like, instead of us doing it ourselves. And you don't need to understand all this, because CellPond does, right? I'm not going to explain all that to you. That's what CellPond does under the hood. It's making all these redundant rules for you. This is how I think about it, right? We could map out every single bit of normal programming from low level to high level. We'd probably have assembly down here and JavaScript and Scratch right at the top, and Dreambird over here. And we could do the same with spatial programming. Okay, so I would say Splat and Sandpond around there, they're extremely low level, very early examples of it. And I'd put CellPond here. That's what I've been trying to do. I haven't been trying to make a very high level language. I've been trying to make a higher level assembly language. And Markov Jr. is another example that does this like differently, but in a really interesting way, and you should also check it out. It's really tempting to try to make a high-level solution to these problems. But I found that it's really hard, because we don't know what these middle steps are. So I'm interested to know, now that we know CellPond is maybe an example of how to go up from the bare minimum, what would the C of spatial programming look like? And we could do this with any field: visual programming, live programming, node-based programming. What's already there? What's next? So my advice to you is to ask yourself, where are you in your field? How low level are you? How high level are you? Because it might save you some time. Learn from my mistakes. I'll tell you where you are right now. You're at the end. Thank you for listening to my presentation.
I'm going to be the first to say that was an amazing presentation. Thank you.
Thank you.
I think this idea that when you find the right primitives, everything kind of falls out is, it's incredible if it happens, but you didn't just find this thing on the first go. You built a whole bunch of things. You tried coming down from the top, you tried coming up from the bottom, you went in from the side, eventually you got this.
Yeah.
Can you talk a bit more about that exploration and discovery process?
Yeah.
How did you know that you'd found the right primitives, and what did it take to get there? Because the eureka moment is like this, you told it like, oh, and then it was there. But, but actually that took you years, right?
Yeah, it took a long time. And I think there was one thing that helped make these primitives arrive. It was CellPond had extremely strict goals. It had a very, very, very strict purpose, and if it didn't hit that purpose, then it just shouldn't exist. So the design stage continued until it would hit that purpose. And the goal was, I'm going to go all the way back to, I'm going to keep going. Okay, here. So this is what I was working with in the time, at the time when I was designing it. The goal of CellPond was to be able to do everything that this language can do, which is called space toad, And everything that I've ever made in Spacetoad, which I have in a repo on GitHub, I need to be able to make in CellPond. So those primitives need to do all of that. And I just kept iterating. I didn't touch like my keyboard until that was in place. There wasn't any, oh, well, it kind of does half of them. And that actually forced me to make some really weird decisions and hard decisions about, you know, when I was making CellPond, this stuff sounded crazy. You know, like when I was first started to sit down, we're going to be able to split them. Like, how's that going to work? The UI just was like the bare minimum of how we make that work. And I think I'd encourage everyone, when you're making something, just know what your goal is and stick to it. Because even if it takes you somewhere you don't expect, and that's what happened with CellPond. Thanks. Any other questions?
This reminded me of two games that I've played before. I wonder if they had any influence. First was an old Flash game called the Falling Sand game.
Yeah.
And the other one was Baba Is You, the rule-based game.
Yeah. Okay. Yeah. Very quickly. Yeah.
Does it relate to those?
Falling Sand games. I think when I first saw Splat. No, I've gone too far. When I first saw Splat in the top right, it just made me think of Falling Sand games, and that's how I first started on this weird journey. So yeah, well spotted. Another one is Baba Is You. Baba Is You is really interesting because in CellPond you have two layers. You have the simulation layer and you have the code layer. But Baba Is You, there's just one layer. And that's really interesting because there's no reflection in CellPond. You can't make the simulation change the rules. The rules can't change the rules are stuck. And so now, with Baba Is You in mind, I'm now building some different stuff where the rules can feed back into the rules and change the rules and stuff like that. So Baba Is You is really interesting from that point of view. Yeah, thanks.
So how do you decide, you have the operations of if this then that, how to you have a color and then you remove one thing and you have a family of colors and then you have ranges and and then you have the mirror. How do you, is there a process to decide which operations to add, when not to add one, when to have, you found one but you keep looking because you don't think it's correct,
right,
or to combine or to split? Do you have a process? Do you have a aesthetic of what rules are CellPond worthy or stuff like that?
Yeah, that's a good question, and I think so this is what you call an asynchronous cellular automaton, and in that world of async CAs, you always have to make that kind of decision. How are we going to apply these rules? What order do we do it? And do we do things at the same time? There's lots of decisions, and CellPond really takes the simplest decision, which is we pick a random place and a random rule. If it matches, we fire it. If it doesn't, we don't. And you just continue and repeat. And that sort of simplicity means that you just don't need to worry about it. We kind of do in another way. It won't have any side effects, but it means you can't guarantee certain things. So I've worked on another thing called Spatial Studio with a good friend of mine, Max Bitka, and we chose a different update scheme for that because we wanted to support slightly different kinds of simulations. But CellPond is the purest, just pure random. I'm going to tell you a secret though. For performance reasons, it doesn't always do that, but it should do that. It's going off spec in those cases. Yeah, don't tell anyone.
Hi, Lou.
Hi, Ivan.
That was very good.
Thank you.
This is kind of a repeat of Mariano's question, but maybe upside down. Mm-hmm. So you've got this UI that doesn't matter and it's not the point, and don't look at the UI, and it's the VM that's the interesting thing. I'm going to look at the UI for a sec. Mm-hmm. How much of the stuff that is in the UI is stuff that you added to the UI because there was something in the VM that's this is a capability that the VM affords. I need some way to let the person get at that? And how much did the reverse happen where it's like, oh, I have this idea for a thing I want to be able to change. I know how I would UI that, but what are the mechanics that's going to enable that?
It was 100% the first one.
Okay.
And basically me making this UI is from my frustrations of, because like you can just write, like you can write out by hand the VM instructions, and it's really like, it's quite fun, all the stuff you can make with that, because you just go crazy. And it was very frustrating to not be able to do that with this UI. So basically, every change in this UI is to allow me to be able to make more of those handcrafted things. And what you can do with the UI is so limited for the VM. And I don't know if this will load sandlab.com. This is like another example. No, that's another one. Don't go to sandlab.cool. No. Oh well. I have another one that I'll show you, and I'll show others around if they want to see, which where I'm experimenting with how to create even more stuff with the UI that you can make on the VM, but not with this. Yeah.
Cool. Thanks.
Hi, so these demos are really amazing. You showed how you can get a lot of functionality without the use of hidden state, but I could imagine, maybe I want my bouncing ball to not, have a consistent color or something like that. I'm curious if hidden state could be implemented in the VM as it currently is, and if not, what changes you might have to make to those abstractions.
Yeah, good question. So, and I think this is related to what I was saying about the main sort of purpose of this project is the virtual machine, not the UI, because I could definitely see how you could, instead of, you could say something like, well, if a cell matches these criteria, then replace it with a sprite and show that instead. What this would benefit, and I hate to say it, what this UI would benefit from would be some words. If you were to try to make a useful game making tool or creative coding tool, if you put some words on and you select, sprite for this color, and then even be able to just embed some JavaScript in or something like that would help. This is an extreme example, if that makes sense. So here is a little mock-up they got. This is a deleted scene. Look at this train track. Because this was something that they, back in the day, they struggled with figuring out is how do we conditionally show different sprites at different parts in the track. So you'd need to do more than this, but this is just a start of the kind of thing you could do. Can you see the inner parts of the track are light blue, we've got the corners as purple, and we have the end as blue. And so it's really quite easy to pick out certain situations. And then you could say, well, we're going to show a slightly different sprite for those things. This is all symmetrical. You'd have to do the corners, but that's the idea. It would be nice if you had a view like that where you see sprites. It would be nice to just toggle, between I want to see the data view, I want to see the sprite view, or even an onion skin thing maybe. Yeah.
Hi, Lou. That was really good.
Thanks.
I know that you said that the UI is not really the interesting part of the VM.
Yeah,
So when you reload the page,
yes,
it does the thing where it's one giant pixel and then it subdivides down.
Yes.
Does that mean anything, or is that just cool to look? Okay, so what does it mean?
You see that?
Yeah.
So this does a lot of heavy caching. This CellPond does so much caching to speed things up. It's the grid. It's not a grid, but the grid is organized in various different data structures, and it tries to choose the quickest one at a given time. That process takes a little bit of time, and it's kind of fiddly to do programmatically. It's easier to just let CellPond do it itself. So every time a cell splits, it will put those resultant cells in the right caches. Yeah, this is all just JavaScript, but it's quick enough. Yeah.
Is that some pre-randomization? Why is it random? Because the evaluation runs every time.
Yeah, so the question was, why is there some randomization going on there? Yeah, CellPond's random, but it turns out like random's fine, you know? Like not all computing needs to be deterministic. Or there is a chance, there is a non-zero chance that like I could set the resolution higher. Like this may never end, just because, you know, the heat death of the universe may come. Like even on a small resolution, that may never end. All of the events, wouldn't that be crazy? All of the events could fire in one corner down here, and then these ones would never happen. But it's never happened to me yet. It's kind of mad, right? Ooh. All right, is that it? Thank you very much. Oh, yeah.
Great. So we it should be on now. Mic check. There we go. So we have a few more minutes before the coffee break, and I thought we've had two presentations kind of about creativity and live programming. So I thought it might be nice to let folks in the audience like ask about that or offer thoughts about that. If you have questions about creativity in live programming, is live programming particularly useful for creative endeavors? How about that for an opening kind of question? Do you find that? Yeah, go ahead.
Shall I answer here? Is that? Yeah, I think play is really important to creativity. I think being able to play around with how something looks, like that fractal example, just lets you discover things that you wouldn't have found otherwise. What about you?
Yeah, no, I agree with this. Like, I think a big component of what has kept me interested in my own project is just building something and then having fun with it, just like I would do with, like, I don't know, Legos when I was a kid.
Yeah, yeah. And obviously live programming is perfect for that because it's not something you do and then it's done. And it's not something you do and then you get immediate feedback. You're just in it, you know. And I think there's like a slight difference there. Like I'm not reaching for an undo button because like I wouldn't reach for an undo, or maybe you would. But when I'm like building something with Play-Doh or like drawing on there's no undo button. It's just like interacting with these materials, like a simulation, like a sandbox. So I think it's a good fit.
It's okay if your hand slips.
You know, it becomes part of the artwork.
Is that different in music? I mean, you have a much more precise kind of thing as you're composing.
Yeah, I would say here the big difference is that I do have a like more traditional programming language, so I need to be careful not to segfault, which is unpleasant when you're working on a creative project. But I do have to say that the discoverability aspect and the like free form aspect of programming in this way makes the act of music making fun in ways that I think are similar to what Lou was describing. Yeah.
Yeah, good.
I'm going to keep asking questions, but okay, good, thank goodness.
Did you ever find out yourself or somebody else using this for something you didn't expect it? Or they ask, can I use this to do? And you say, what? Why would you want to do that?
Yeah, so CellPond, I occasionally just search for it on YouTube, and I'm often quite surprised with the kinds of things people have made. And I'm really surprised by the range of things, because some people just use it like just to draw pictures, which is nice. And I think that's why, like in these demos, I'm now just putting more time. Look, you can make paintbrushes. And this is something I learned from working on Spatial with Max Bittker. Sometimes these tools don't get used for coding until much later on. I've seen some very intense fluid simulations, and my favorite was from this week. and they might be watching. I don't know. Someone, Among Us. Like the character. They made a fractal where it was the shape of an Among Us character, and then in each part of the body there were more Among Us characters, and then in each one of those, is it Amogus? I don't know. Anyway, yeah, it's always very surprising.
Yeah, in my case, I would say the thing that I didn't expect is how much I would get into learning more about like actual electronic music and how to build effects for music and so on. Like this really wasn't something that I really thought about when I went to do this project, but it's so natural to be able to peel off layers of abstraction and then put them back on. That is just a natural part of making music with PA. But maybe it's also just because there's nothing, and so I need to build everything. So I don't know that a user that's using something complete would have the same experience, but I kind of hope so, because it's a great opportunity for learning, and it's really fun.
Peter, there's a question in Discord for Lou, if someone wants to read it out.
I could.
Lou is someone. All right. I have a question. Yeah, sure.
Oh. Should I take this? Yeah.
Is it long?
No. Continuing the hidden state question, can CellPond have several layers on top of each other, or even go full 3D or 4D? 4D, wow. So that's a good question. So I used my earlier stuff was in 3D, SandPond, but that's still quite a good fit for this 2D rule manipulation, because you just end up only working in a single plane at a time. So like a rule can only work in 2 dimensions, even though it's within a 3-dimensional thing. Maybe that's the same with 4 dimensions. Never thought about it. But of course, like it's harder to see inside 3D stuff. That's the challenge. If anyone knows a solution, maybe it's VR, I don't know.
Exploding diagrams.
Yep.
That brings us to our first coffee break, though. Oh, I see a question, Todd. Is it a quick one?
Yes. For Xavier, when you are composing, most of us who have seen sheet music think of sheet music and the compositional attributes of musical notes and whatnot. When you're composing using your tools, do you think of the programming language that drives it as the creative visualization?
I mean, right now I mostly think of it as a hindrance, I would say.
Okay.
But eventually that is kind of the goal. I think if you look at live coding, which is what I'm trying to approach with this project, now, it wasn't really what I was going for at first, but it's kind of what I'm going for now. You can really see the like source code as really a creative medium for representing music, and so I think there is that aspect to it. Does that answer your question?
Yeah, perfect. Thank you.
All right. Well, for those online, we're going to take a half-hour coffee break. We'll be back in 30 minutes or so. Thank you to our opening speakers. You brought us to a great start for the day, and yeah, see you in half an hour.